Hello everyone, I am Professor Musheer Ahmad, Department of Applied Sciences and Humanities, Faculty of Engineering and Technology, Jamia Millia, Islamia, New Delhi. Today I am going to deliver a talk on development of number system. How the number system is developed from the scratch to complex number system. Initially in ancient times, the humans used to interact with each other through various types of numerals, namely Babylonian numerals, Chinese numerals, Japanese numerals, Korean numerals, Hindu-Arabic numerals, Roman numerals, Greek numerals, Chinese rod numerals, as it is evident from the given figures. They actually interacted with the use of these numerals with each other through counting of numbers, through counting of fingers, through counting of peanuts, animals, and the human beings. The number system is nothing but a writing system for expressing number. That is a mathematical notation for representing numbers of a given set, using digits or other symbols in a consistent manner. The number system, what we have today, is commonly called Hindu-Arabic numerals. It came about because human beings wanted to solve problems and mainly wanted to know the quantity of a particular thing. So they started creating numbers to solve these problems. In olden days, the counting numbers satisfied people for a long time. For example, counting through fingers, counting of peanuts, counting of balls, counting of human beings, etc. Natural number. How natural number system was developed? The natural numbers are nothing but the ordinary numbers like 1, 2, 3 and so on, with which humans count. Sometimes they are called the counting numbers. Natural numbers have been called natural because much of human experience from infancy deals with discrete objects such as fingers, balls, peanuts, etc. People quickly, if not naturally, learn to count them easily. The natural numbers are presumed to have started before recorded history when humans began to count things. The Babylonians developed a place value system based on the numerals for 1 and 10. The ancient Egyptians added to this system to include all the powers of 10 up to 1 million. Natural numbers were first studied seriously by a great philosophers like Pythagoras in the year 582 to 500 BC and Archimedes in the year 287 to 212 BC. Natural numbers are discovery of zero. Though humans have always understood the concept of nothing or having nothing, the concept of zero is relatively new. They wanted to find some number to represent a nil value. So they found zero to represent a nil value. The human beings of that era got zero to represent a new value. Many mathematicians of different era has suggested for symbolizing nothing. Then they introduced the symbol zero for symbolizing nothing to the word and made complicated things very easy. Indian text used also a Sanskrit word shunya. That means shunya referred to the concept of void. In mathematics text, this word often refers to the number zero. Integers. Then comes to the integers. When we come across an equation of the type x plus 2 equal to 0, if you go on solving this type of algebraic equation, then we find the solution is nothing but x is equal to minus 2, which we know that it's not a natural number. So with the introduction of these negative natural numbers, a new number system was discovered at that time. and mathematician of that time called it a integers number system. So integers are nothing but a union of natural numbers, negative natural numbers and zero. When you add, subtract, multiply two integers together, you will always get an integer as the result. However, if you divide two integers, the result is not an integer. Therefore, this system for division is not valid. The integer was introduced in the year 1563 by Abermouthhost. Then it is further developed in the year 1890 by a Japanese mathematician who worked on it and created integers, which is in Latin word meaning untouched. The symbol for integer is Z because of Zahlen, the German word for integers or number. Then comes the further development of the integer number system, which is a rational number. When we come across the equation like 3x plus 2 equal to 0 and we solve, then the solution is nothing but x is equal to minus 2 by 3, which is neither a natural number nor an integer. So mathematician of that time found a new number system, and which we call at that time the rational number system. So rational number is a number which can be expressed as a fraction with an integer numerator and a non-zero integer denominator. Rational number is usually denoted by a bold-face Q. Then comes the concept of irrational number system. The concept of this irrational system came into existence after encountering the various problems of algebraic equations, like when we solve the equations like x square minus 2 is equal to 0. After solving these equations, the solution is nothing but x is equal to plus minus root 2, which contradicts the very basic definition of rational number. If you go through the definition of rational number, root 2 is not fitting the definition of rational number. Therefore, the mathematician of that era call these type of numbers as irrational number. To introduce this concept more logically, an ancient Greek philosopher whose name was Hipposus, who happened to be a student of Pythagoras, he actually used his teacher's famous theorem, which we call it Pythagoras theorem, which is a square plus b square is equal to c square, which is a formula derived from the right angle triangle. To find the length of the diagonal of a unit square, he revealed that a square sides are incommensurable with its diagonal, and therefore that this length cannot be expressed as the ratio of two integers. So they invented a new number system which is called as irrational number system, and the set of irrational number is denoted by IR. Then after that, to further develop this rational and irrational number system, a new real number system came into existence. And this number in mathematics, a real number is a value of a continuous quantity that can represent a distance along a line. The adjective real in this context was actually introduced in the 17th century by René Descartes. He actually changed the entire concept of number system. The real number, according to his, include all real rational numbers such as the integer minus 5 and the fractions like 4 by 3 and etc., and all the irrational numbers such as root 2 and so on. The square root of root 2, which is an irrational algebraic number, which also include within the irrational numbers are the transcendental numbers such as pi. In addition to measure the distance, real numbers, in addition to measuring the distance, real number can be used to measure quantities like time, mass, energy, velocity, and many more. Therefore, a real number can be thought of as points on an infinitely long line called the number line or real line, where the points corresponding to integers are equally spaced. So, any real number can be determined by a possible infinite decimal representation, such as that of 8.632, for example, where each consecutive digit is measured in units 1/10 the size of the previous one, which can be shown by these diagrams here. On the left hand side, a diagram which is depicting the real number system, which is starting from the very basic natural number system, followed by the whole numbers, then integer number system, rational number, irrational number, then come to the real number system. The real number system was actually many years of that time philosopher thought it is a complete number system. There is nothing beyond this number system. People of that time, when they encountered with the algebraic equations like x square plus 4 equal to 0, after solving these type of equations, they found that the solution of these type of equations are nothing but x is equal to plus minus under root minus 4, which is not a real number. So this contradicts the very basic theory of real number. Therefore, the mathematicians and philosophers of that era considered that there is definitely something which is beyond the real number system, because as it is evident that after going through this type of equation, the square of a number is a negative quantity which is not a real number. Therefore, a new number system was thought to be operational to overcome this type of algebraic equation. Therefore, the philosopher and mathematicians of that time introduced a new number which we call it as imaginary number, whose square is nothing but a fixed quantity which is equal to minus 1. Therefore, by introducing this concept of imaginary number, which is called as iota, a new number system was developed, which philosopher of that time called it as complex number system. A complex number is nothing but a number which can be expressed in the form of a plus bi, where a and b are real numbers, and iota, which is not a real number, because iota is not a real number. Therefore, a complex number can be redefined as a plus bi, where a is called the real part of a complex number and b is called the imaginary part of a complex number. By introducing this complex number, a mathematician of that time, Descartes, introduced this concept that every complex number can be represented as a point in the plane, and every point in the plane represents a complex number, which can be easily depicted by these figures which are given here on the left hand side as well as on the right hand side. By introducing this complex number system, the entire number system got a new dimension. Previously, up to real number system, which you look at, this can be represented, every real number can be represented on a single line, which is a one-dimensional case. But when we look at a complex number, which is nothing but a point in the plane, therefore, a complex number system is nothing but a two-dimensional case, which is a plane. Therefore, from real number system to complex number system means from switching from one-dimensional case to a two-dimensional case, which change the entire theory of number system. That's all, my dear fellow, about the development of this complex number system. Thank you.